Today we're going to take a look at the Prusa Pinda 2 probe and how you can use the thermistor that's inside it with Marlin firmware to make your auto bed leveling more accurate. So to start this video, let's step back a bit. When I first got my Prusa Mark II printer, I noticed every time I changed filament, like from PLA to ABS, I'd have to adjust the first layer. And it really wasn't that big a deal because there are features on the printer to adjust it, but it's just one more thing that you have to do. And a lot of the Marlin printers, you can set baby stepping to help you out with that as well. Again, it really only seemed noticeable when you're making large bed temperature changes, like going from PLA at 55 up to ABS at 100, or back down. I'd always have to come in and readjust that first layer. Now you can go in and live Z adjust on a Prusa printer and make that happen, but it's not the most convenient thing to do every time. And that's where the Pinda 2 probe comes in when they started building the Prusa Mark III printers. So on the Mark III, they introduced the Pinda 2 probe that has a thermistor inside it, so they can take readings of how warm the probe might be and try to compensate for the differences in temperature versus bed level. And that has all been baked into Marlin as well. So now on your Marlin machine, after you wire a few things up, you can set up pretty much the same scenario and try to get a more accurate bed level. So that's what we're going to do today. We're going to walk through all the steps to get a Pinda 2 probe set up on your printer, go through all the calibration, and before we get started, we're going to take some generic measurements, a cold bed, a 60-degree bed, and a 100-degree bed, just to see where our map is now, and then where it will be after we get all of the Pinda 2 probe items set up. So let's jump right into it. When you purchase a Pinda 2 probe, you can get these from Prusa or from Printed Solid. You will have 4 wires in a connector like this. The brown wire is positive 5 volt, the blue wire is ground, the black wire is signal, and then the white wire is the thermistor data. You can hook these white wires up to any analog pin, but the default configuration in Marlin is to use the second extruder's hot end thermistor pins. So for example, on your SKR board, the SKGO printer does currently have an SKR 1.4 turbo on it right now, so that's the board we're going to be using today. But you have an extra stepper socket for a second hot end or extruder, as well as a plug for that thermistor for that additional hot end. So by default in the pins file, you will be using these pins. Now since this sensor already has ground when it's hooked up over here on your minimum end stops, you only need the pin that provides the data. So on an SKR board, your white wire would go on this pin right here. So for my SKGO configuration, I've broken the Pinda wires out into one JST plug, and then the white wire out to a 2 JST plug, just with one wire hooked up. The probe portion will go in Z minimum end stop right here. And the thermistor wire will go into this TH1 plug right here. And as far as hardware, that's all you have to do to use a Pinda 2 probe. The rest will be in the Marlin configuration. And from there, it sets up just like any other auto bed leveling probe. I do have videos on that. I'll leave links to it. And you can use that probe without using the thermistor wire. But if you don't want to use that wire, you might as well just get a Pinda 1 probe, because other than that, they're pretty much the same thing. Now we're going to test this probe before we make any changes to Marlin, just to see how accurate it is at different temperatures. And before we start the test, I actually do have to make one quick change to Marlin to be able to use the Pinda 2 probe, or any Pinda probe. These probes are usually set normally closed. So when the probe happens, it will go open. The other generic sensors that I use are usually normally open. It's not a huge change, but to use the Pinda style probe, you will have to change Z minimum end stop inverting to false. And if you change that one, you have to match the Z minimum probe end stop inverting to false as well. That's the only change we're going to make before we start the test. We'll go ahead and upload. All of these tests will be ran with the hot end off and different ranges of temperature on the bed. The first before test will leave the bed off. It is important to note it's 22°C in this room right now, and that temperature can also affect things. So when testing something like this, try to have a regulated room the best you can. We're going to use the standard G29 command with auto bed leveling by linear. We're going to do a 5x5 grid for a total of 25 points. The first probe will be at 8,000 millimeters a minute, then the accuracy probe will be at 4,000 millimeters a minute. So 2 probes for each spot. And remember, we're not judging the accuracy of the level of this bed. I'm really not sure what it is right at the moment, but it's more about the difference in how the probe heats up while it's leveling. Remember, it's always a good idea to run an M500 and an M502 before you start anything. So here's the first set at 0. And here's what that first run looks like. It's not the most accurate probing I've ever seen. It's a little bit all over the place, but not as bad as I actually thought it would be. We have about 200 micron in between left and right on that back row. On the front row, there's almost a millimeter difference. So it could use some help, but nothing that auto bed leveling can't handle. Now what we're going to do is move the probe to the center of the bed. I'm going to do a G1, X150, Y150. Then I'm going to heat the bed up to 60°C, and when the bed gets to 60°C, I'm going to set a timer for 5 minutes and let it sit there and warm that probe up. Remember, we're not necessarily interested in how level that bed is. It's more of a comparison of what the probe reads at different temperatures. That's what we're trying to compensate for. The bed has hit 60°C, so I'm going to start a timer for 5 minutes. Then we'll go ahead and do another G29 and see how it's changed. It has been 5 minutes. We have set with the probe in the center of the bed at 60°C. So let's go ahead and run another G29. And here's what the 60°C probe looks like. It's pretty close to the cold one. If we scroll back just a bit, I will put these up side by side. We're about 40 micron different in the front corner, but we're almost exactly the same on the back row. So the probe really isn't affected all that much by 60°C. You'll see more of this when we turn that thermistor on, and it'll be a little bit more clear about what the probe does as far as heating up. Now we're going to do the same with 100°C. So I'll set the bed to 100. We'll move to the center of the bed again to allow the probe to heat up. We'll wait for the bed to get up to 100. We're at 100. We'll go ahead and set another timer for 5 minutes to allow that probe to heat up, and then we'll take another G29. Our 5 minutes is up. We've been setting with the probe in the center of the bed. The bed is at 100°C. Now let's go ahead and run our G29 again. And here's our map at 100°C. Not actually as off as I thought it would be. It is starting to creep up a bit. I will show them side by side. It's important to note where the nozzle is right now. M114. We're almost 6 millimeters above the bed. And you'll notice in pronter face, up here, the hot end is actually getting a bit of that heat from the bed. So I have no doubt that the bed heat is impacting that probe. But it is possible that that probe could get even warmer. We just let it set for 5 minutes. Again, you'll see more of this when we get everything set up to use that thermistor. And that's exactly what we're going to do now. Let's jump into Marlin, get everything set up so that we can use the thermistor inside the probe, and we'll do the compensation calibration and see how it affects these numbers. The first thing you will need to change is the thermistor for that probe to activate it. In thermal settings, that probe uses a 100K thermistor, which is a number 1. So down here for temp sensor probe, we'll just put a 1. Now there are some syntax changes recently in Marlin that it's going to complain about when you try to do this. So when we build, I'll show you how to correct those. There are a couple of them, and I'll show you what they do. But I also want to show you the trail of how it knows what thermistor port to use for this temp sensor probe. So we're going to go to Explorer, we'll open up Source, we'll go to Pins, and we'll pop open LPC 1768 because I want to look at the common files for the Big Tree Tech SKR boards. Most all of the SKR boards have these common parameters shared. So they're all in this file, and then they're included in the other pins file. So we'll take a look at the common file. If you scroll down just a bit, you'll see this statement. If the hot end equals 1, and you have the temp sensor probe enabled, your temp probe pin is going to be temp 1 pin, which is assigned up here. You can see it's listed as T2, and that is the probe address that you would see on the back of the board. I just thought it might be handy to show you this, to show you how the board figures out where you need to put that thermistor. So let's go back to configuration.h, and I'm going to let it build. Go to platform IO, 1769, I'll just hit build, and you can see all the error messages. You can see it's talking about PTC park position. It's now an array. So the syntax has changed somewhere in between the two versions, and I need to make that update manually. If you go to the newest version of Marlin, that has probably been updated for you, but it's easy enough to make this change. So I'm just going to copy this. I'm going to head to configuration_adv.h, and I'll search for ptc_park. Here what the old values look like. I'm just going to comment these three out. All three of these values have been placed in an array. So I'll paste them in right here. We do have to define it. And this is the location that you want to park in during the calibration setup so that the probe will cool down, get back to normal, before it starts another sequence of calibration. Optimally, you want this off of the bed area. So I'm going to set mine for 0x, that's in the front corner, that's fine, comma 290. That will put the head all the way back in the Y position, but allow the probe to hang over the bed out of the bed area. So it should be able to cool down a little quicker. And I'll do comma 100 for Z. So that'll drop the bed down 100, again keeping the bed away from the probe during the calibration, so it'll cool down just a little bit faster. The calibration does take a long time, so anything you can do to make it go faster, the better. And we will have to clean up a bit more of our syntax down here for probe position, but I'm going to go ahead and let it build so you can see the error. I think it helps to see the error to help troubleshoot things in Marlin going forward. And you'll see it's complaining about the same kind of thing. The PTC probe position syntax is no longer correct. So right below it, we'll do this again. We'll comment out these two lines. We'll define a new one called PTC_probe_POS, and then space, parentheses. This is the position of the probe like we did back in the test, where we're going to allow it to heat up during the calibration. I'm just going to put it somewhere in the middle of the bed. So depending on your printer's size, I'm going to do 150 for X, 150 for Y. This is just trying to get it in an area where the bed will impact the probe the most, so we can calibrate it. This setting right here is also important to mention. The PTC max bed temp, it's going to try to set your max bed temp during the calibration. That's saying that it's going to try to calibrate at the maximum possible bed temperature that you're going to run. So you want to make sure that bed max temp is set to something that you expect it to be set at, not a ridiculous temperature. So if we head to configuration.h again, we're going to take a look at bed max temp. It's right underneath the therm settings. Mine is currently set at 150. That's a little high for me. So I'm going to set mine to 110. Be sure you check that if you're running this calibration sequence. And let's go back to configuration advanced one more time. And let's talk about use temp extruder compensation. These values aren't calibrated automatically yet. This is still kind of an experimental setting. I am not going to test this out for two reasons. One, I can't get it to compile when I turn it on. It complains about some settings in the code that I'm not sure what it's talking about, so maybe we'll test this in a later version of Marlin. But the second reason is my probe is a long way from my hot end. It's actually almost 60 millimeters behind it. So I don't know how much the hot end would actually impact the probe anyway. I'm mostly concerned with the bed impacting it. So I'm not going to test that function today. But this should be all we have to do to get set up and working. So let's go ahead and hit build. Oh, and I threw an error when I tried to build. These are actually treating these as integers. I actually need curly brackets on these. Future Chris will leave you a note on that, but we'll go ahead and build again. So we have built successfully. We can go ahead and upload. I will turn the printer off and on to pull in those settings. We're going to jump back into printer face and connect back up. We did make some changes, so we're going to reload EEPROM M502. We'll save it with an M500. And you'll notice over here in printer face, now you have your hot end temp, your bed temp, and your probe temp. So the probe is currently setting at 36°C, so it is definitely a lot hotter than it would be at room temp. And now we need to calibrate. Marlin does have a pretty good guide on how to do this configuration. I'll leave a link to this for sure. Just because we added the thermistor for our probe, we're automatically going to have probe temp compensation enabled. We saw that in Marlin. We have checked our max bed temp. We're good there. We have adjusted our park position. This is where it cools down. We have adjusted where we're going to heat up, right in the middle of the bed. And we're going to skip the extruder compensation. So now we can start the calibration process by running a G76. Now this does take a while. But remember, while this is running, we're looking at these values right here. So it's going to go through that calibration and make a map. So as the probe heats up, it's going to save a micrometer value about how much the probe needs to compensate, as well as how the distance increased for the bed as it heats up. So let's go ahead and run our G76. It will take care of all the homing, heating, parking it in the cool positions, all of that for you. So let's just kick it off. Our bed was already up to temp, so it's going to wait for it to cool down. Once we're cooled down, we're going to move into our cool position. So we're dropping the bed 100. We'll stay at X, but we'll go to that 290 position in the Y. We'll go ahead and start our timer, but it's waiting for bed and probe temperature. It's taken its first cool measurement right around 29°C for the probe. Now it's going to heat the bed up to the first increment of 60°C while moving to the hot location right in the center of the bed. It lets the probe heat to 30, takes a measurement, and then we move on to bed 65, probe 30, and we'll take another measurement after another cool down sequence. And we'll just work our way all the way to 110°C on the bed, and then after that it's going to spit out all the values and we'll take a look. Let's let it run. And we're done. The probing calibration took almost an hour. If we scroll back up a bit, the first thing it did was go through all the different bed temperatures and wait for the probe to get to 30. The probe pretty much stayed at 30 during the whole sequence. It didn't have a whole lot of time to cool down, but that's okay. You can see we got 8 measurements at those different temperatures of the bed, and then it applies linear extrapolation for higher temperatures. So basically, it's just saying that it's going to use the same trend that it saw at the other temperatures. And then we start with the higher probe temperatures. So we leave the bed at 100 and we cycle on through. We only got a couple of measurements because the highest probe temperature we saw was 46. It waited for it to get higher than that, but it never did. So it timed it out and said I only got 3 measurements. Again, it's going to use a linear extrapolation for the higher temps. And these are the calibration values we ended up with. It's going to give you an offset for probe temperatures as well as bed temperatures, and it's going to use those to try to compensate when you're at those temperatures. So basically it's making very small Z adjustments. But now the calibration is done. I saw the hot end temp around 50°C at the most, and then the probe temp again set around 46. It never got much higher than that. You can use an M871. That will show you the values again, but you can also edit those values. If you think one isn't quite right, you can adjust this table, or after you start using this and you go up to that temperature, but your offset isn't high enough, you can adjust it with that M871. So for our M871, let's just say we want to edit the bed iteration. So we'll do M871B. We want to edit iteration 2, and we're going to change it to a value of 20 micrometers. Hit enter. Then you can do that M871 again, and you can see that iteration has been changed to 20. These do start at 0, by the way. And that's just if you want to change one. I'm going to change it back to what it saw in the calibration, and that was 127. So far this is just saved in memory, but you can save it in EEPROM, so it's there over reboots. We'll just run an M500. If you want to clear this out and run your calibration again, you can run that M502 to bring in the stored values, but you will have to run that hour-long calibration. You can also run an M871R to reset all these values to 0. So basically default. So now we're going to run all of our tests again with all these offsets applied. During the G29, these offsets should be added to those values based on what temperatures you're set at, bed and what the probe senses. So I'm going to let the printer cool down, then we'll do our room temperature test, our 60°C test, and our 100°C, and we'll compare them at the end. We're back down to pretty much room temp, around 25 on the bed, 24 on the probe. So let's run our room temperature G29. So there's our room temperature map. We won't take much time looking at these right now. We will line all these up at the end. But for the 60-degree test, I'm going to go ahead and set the bed to 60. I will move once again to 150, 150. But this time, I'm not going to start the G29 until I see the probe temperature stop rising. So the thinking is I want to run my map when the probe is at its hottest, when the bed is at 60°C. I'm going to do the same thing on 100. So we'll just wait a few minutes. Now while we're waiting for the probe to heat up, since this is kind of a bed leveling video, I wanted to introduce you to debug bed leveling. So let's head back into Marlin, and in the bed leveling section, you'll see the line item debug leveling feature. Just take the comment off of that. This enables you to get a whole lot more information about what the probe's doing during a 28, a 29, and M48. It's going to tell you where it's moving to, what distance was sensed, and if you're having a problem, like when you first start your leveling and the probe just stops on the first point, this is going to tell you why. It's a great feature to have if you're having issues getting your leveling just right, or the probe isn't functioning how you think it should. If you're on a 32-bit board, you'll be fine. Some 8-bit boards might not have enough memory for this feature. So after you turn it on, you can use an M111 S32 to see all the info. So back to Pronterface, we'll just go ahead and run that command. M111 S32. Debug leveling is on. So we've been waiting for around 15 to 20 minutes for that probe to heat up. The hottest I've seen it is at 35.08, so I think that's as hot as it's going to go with a 60-degree bed. And now we have our debug turned on, and when we run this G29 for the 60°C test, you're going to see a ton more info. We'll let it run through, and then I'll show you an example of what one of these debug entries looks like. So the G29 is complete. Here is our map. Again, we won't worry about the entries too much for now. We'll look at those here in a minute. But let's just take this last probe for an example. So the maximum area that we move to when we're probing is 268 on the X and 226 on the Y. So it finished the second to last probe, and then we're going to move to our last probe location. We're going to send the Z down -10. It just does an overshoot movement to make sure that it's going to probe. Our first probe was a 0.89. Then we reset and do our second probe right here. Our second probe was a 0.88, discrepancy of 0.1. Then we're going to move up 5 millimeters because that's the safe motion. You'll see that 411 in here a couple of times. We have it set to 5, so it goes out of the negative, that 0.88, and then finishes on up to 5 with a 4.11. That's just the amount of Z that it moves up while it's moving to different points. And then the probing is complete. So if you see probing errors during your G29, this is a great feature to turn on to try to figure out which probe is causing problems and why. It's going to spit out all that error information right here. So definitely check that out if you have issues. And if you'd like to know how this correlates to this measured point based on what the probe saw with the 0.89, 0.88, how does it get to that 1.6? Let's pull up our calculator. If you take a look with the M851 command, that shows you your offset. We have a Z probe offset currently of 0.77, so we'll take that, 0.77, plus what we measured during the debug. We got an 8.8 and an 8.9. It's going to put those two together and come up with a calculation, so we're not going to get it exactly right, but close enough. Let's just go with 8.9 plus 0.89. That gets us to 1.66. We measured a 1.679. So then you take into account the offsets for that thermistor inside the probe. Bed temperature of 60°C, we have no offset. But our probe was hovering right around 35°C during this test. That gives us a 15 micron offset. So back to our calculator, we're just going to add 0.015. That gets us to 1.675. We're at a 679 on this measurement up here because of the math it does between two probes, and that's how you get to that number. So that kind of shows you how this feature calculates these numbers and offsets based on the temperature of the thermistor inside that probe. Hopefully that makes some sense. Now we're going to move on to the 100°C test. So I'm going to heat up to 100. I'm going to move the probe to the center of the bed. And just like for the 60°C test, I'm just going to wait as long as it takes until I see that probe stop heating up. So about as hot as I saw that probe get was around 43°C, just a little bit above, with a 100°C bed. So we should be good to go ahead and kick off our G29. Let's go ahead and kick that off. And here's our map. So now let's take a look at all 6 of these maps side by side. The 3 we did before the temp probe calibration, and then the 3 we did after. Remember, room temperature, 60°C, 100°C. So here we go, here are our results. You have the before we did the compensation on the left, and after on the right. And this really isn't telling you a whole lot of information actually. You have the room temp measurements up top, the 60°C in the center, and the 100 down below. All this is really confirming is the fact that when the probe temperature rises, the bed offset gets greater, so the measurements on 100°C are going to be greater than it is at room temp. And again, these are on a micron level, but it can be enough to ruin your first layer. And it also proves that the offset for that temp calibration for the probe is being applied over here on the right side versus the left side. So it's definitely doing its job, and if you're seeing this type of issue when you're switching out to different filaments from low temp to high temp back again, it's definitely something worth looking into. And our testing is complete. So there it is, hopefully everything you need to know about setting up a Pinda 2 probe with Marlin and using the thermistor inside it to try to get a better consistency when moving around to different bed temps. Now of course this isn't a fix for everything, it doesn't work perfectly. But if you're already using an inductive probe, this might be something you want to check out. The Pinda 2 probe isn't much more money than a regular inductive probe, and it's pretty easy to set up. So if you're looking to get just a little bit more consistency when you're using different filaments, maybe you go from PLA to ASA quite often, it might be the setup for you. Hopefully you found this helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below, and as always, thanks for watching.